Yes, hello everyone. I'm Erica Yang from the UK, from a company called Chiltoncomputing. We are an AI software company. In this particular project, this project is called ADA. We are focusing on e-health. Specifically, is in the health domain that involve a lot of remote health, self-care, self-managed healthcare delivery at home and care home for elderly. So as some of you, if you work in the healthcare sectors, you will surely aware that globally now, particularly since COVID, this whole movement of telemedicine, telemedicine and all that sort of delivery at home, you do it at home as much as part of the diagnosis and the healthcare delivery process is actually becoming more and more a reality. So what that actually means is that in the UK, for example, we have a new trend, which is actually already starting, entering mainstream, is something called virtual ward. Traditionally, hospitals have wards, right? Maternity ward and this ward and that. But often when after people discharge from hospital, they are sort of disconnected from, from the hospital at least. But however, because of a lot of development in the world, aging population and all that, that means that remote healthcare delivery is becoming more and more central in Europe, in UK, in US, globally. So this project particularly trying to say is that it's all great, the movement is great, but however, this is extremely expensive and inaccessible to vast majority applications and patients and all that. So we, in this project, asking the question is that what kind of network capability, particularly in terms of the Open RAN RIC capability, can we exploit to help addressing those issues, addressing those healthcare delivery issues. I will go into that a bit more. So the overall purpose of the project is really to make this quality self-managed healthcare more accessible and affordable to all at scale. So how we're going to do that is, this is a bit sort of, anyway, an earlier version. So the main benefit we see that is if we push down, if you remember what we have heard so far today, a lot of talking about network intelligence bottom up, and then another one is talking about making it more aware of the application capability and the application more aware of the network capability. This project is trying to leverage that two-way communications and trying to ask that questions, what kind of capabilities in the network can we exploit to support a more advanced analysis so that both end, the patient end and the healthcare institutions or hospital or healthcare professional side can be supported by this kind of network intelligence on-demand delivery of analytics, but providing that at the edge of the computational network. Provided by the telecom providers. So we anticipate 50% faster and more accurate responding to complex needs by healthcare professionals and without additional training and resources. So what that means, one example is that a lot of this remote healthcare support and delivery is supported by voice, supported by audio, video and all that. So we're trying to say pushing that intelligence down into the network, but making that more accessible to different kinds of application. Particularly, basically, that means that healthcare professional doesn't have to be all very knowledgeable about every single complex scenarios by doing that. That's the benefit we are envisaging. So the value add we were going to do is offloading the computational intensive AI power medical analysis or analytics onto the network and leveraging that network intelligence automation hopefully could be enabled by this RIC application, real-time application. This will be quite, we would say it's a future forward-looking application, a proposal, in the sense that it will be exploring a new type, next generation perhaps next generation applications that exploiting this type of capability. As you know, that network layer is actually also fast evolving space. It's not set in stone really. So, but we're trying to understand how do we do that. So in terms of, this looks like a mini CV, yeah, a little bit. But basically we have a lot of experience with European project and as well as in the UK. We are ourselves, Chiltoncomputing is an AI software company, but in this particular case, we also work with other companies who has experience actually being CELTIC, for example, CELTIC coordinators and all that. So I'm not going to go through this. If you're interested, do feel free to look into this. In terms of the visions, that the longer-term vision is that everyone can enjoy the personalized, quality, and affordable healthcare. But really, what that means is that by this will be delivered by what we call the e-health assistants or deployed on the network, on the edge. We heard a lot about edge computing today, and then deployed on the edge, making it much more context aware of the real-time interactions and the communications between two ends of these scenarios, so that this type of intelligence can be used to interrogate, understand, sense, interpret voice, text, and conversational context and all that, and take into account in that two-way communication, two-way interactions. Right. Are we time yet? Oh, yeah. Okay. So in terms of the motivation, I mentioned that at the beginning, is that really that, well, certainly in the UK, we are under tremendous pressure. The healthcare system is under tremendous pressure in terms of recruiting and training more and more healthcare professionals. So that's something we're trying to address by providing this kind of on-demand support on-demand assistance in terms of understanding the medical context, understanding how to interpret that, and providing that help in real time to the professionals, and if in the right application for the patients or for the people on the other end as well. Right. Again, in terms of the immediate outcome of the project, we are looking at particularly sort of understand the technology stacks. We will develop the technology stack for this type of application in e-healthcare. But more particularly, that's the software. But more particularly, these software stacks will be demonstrated by the proof of concept. This will validate it, we call it in phases throughout the project. This is a 3-year project, so initially that will be a 3-year free POC deliver throughout the project with different level of maturity. And in terms of the longer term, we are looking at contributing to standards, but also particularly ETSI and Open RAM standards. But also, another important longer term impact we are hoping to build up towards is this European/global value chain partnerships across this e-health Open RAM stack and as well as AI software for this application. Partners we are looking for. We already got partners, as said, actually partners bring other partners as well. So from other existing or previous project. So we are looking for more other types of end users, if you like. We do have, for example, VR headsets, VR app developers who are catering for e-health, delivering those kind of VR application for home use. So that's for clinical grade home use. So it's not just a normal VR headset and all that. So, but we are looking for more if you have a digital health company developing wearables and medical grade wearables particular. So we will be interested in hearing from them. And see how to work with them. Of course, we are interested in the telecom service providers if they are interested in this type of next generation applications, and the RIC technology stack providers, including those software stack providers. In terms of AI developers, we are also looking for people who are well, basically can provide APIs in terms of real-time voice transcription software, but also in terms of the federated learning, because security, I didn't highlight that in the previous slides, but security and privacy is a huge issue in this context. And we are looking quite deeply. We will have a dedicated work package on that in this project. Right, here's my contact detail. You will be able to find me. Do feel free to get in touch if you're interested. Okay, thank you.